Today we are going to see some MCQ problems related on singularities. Before that we can see some introduction of singularity. So singular point means a function fz fails to be analytic at the point z0, then we can say z0 is said to be the singular point, or else we can say that the function is to be analytic except at the point z0, then we can say z0 is the singular point. So there are two types of singularities there, isolated and non-isolated. For the isolated there are three types: removable, pole and essential. Let's see what is removable, pole and essential. So for the removable, if the limit exists or finite, then it is removable. If the limit is equal to infinity, then it is pole. If the limit does not exist, then we can say that is essential singularity. Or else we can say if it consists of no principal part, that is removable. Pole means it consists of finite number of principal part, and for essential there are infinite number of principal part. So let's see what is principal part. Let's see Lorentz series expansion, which is of the form summation n equal to 0 to infinity a n z minus z naught the whole power n plus summation n equal to 1 to infinity b n divided by z minus z naught the whole power n in the annulus region. Said to be regular part, and this is said to be the principal part. Let's see the MCQs. The first question, for sine z divided by z at z is equal to 0 is. Let's see the solution. Limit z tends to 0, sine z divided by z. We have the result that which is equal to 1. So it is the limit exists and also finite. So as per the condition given before, we can say that if the limit exists, then it is a removable singular point. The second question, if fz is equal to e power z plus e power 1 by z as z equal to 0 and z equal to infinity is. So first let's check for z tends to 0. So while applying z equal to 0, you will get e power 0 1 plus e power 1 by 0 e power infinity, and that gives infinity. And here limit z tends to infinity, apply the z value so that you are getting infinity. If the limit is equal to infinity, then we can say that is pole. The third question, if fz equal to z minus sin z divided by z cube have. The solution here, so z equal to 0 is the singular point. If you put z is equal to 0 in the denominator, you will get fz is not analytic. So if it is not analytic, that point is the singular point. So z equal to 0, you are going to apply here. So limit z tends to 0, 1 by z cube, z minus, this is the sin z value, series z minus z cube by 3 factorial plus z power 5 factorial. Hence these two get cancelled, write the remaining. After that, z cube you can take outside, cancel this, the remaining is 1 by 3 factorial minus z square by 5 factorial, so on. Apply z tends to 0 to the remaining, you will get 1 by 3 factorial. So the limit exists, hence we can say that it has removable singular point. Next question, a function f is equal to e power 1 by z at z equal to 0 is. Now apply e power 1 by z series, that is 1 plus 1 divided by z by 1 factorial, 1 divided by z the whole square by 2 factorial, etc., which is this. Now you can realize that it consists of infinite number of principal part. Principal part is nothing but the negative powers of z minus z naught. So here you can say the denominator, if it bring to the numerator, it has negative power. So principal part, it consists of infinite number. So this condition for essential singular point. Next question, a function f z equal to e power z at z equal to infinity is. So in the last problem you can say that z equal to 0 is the essential singular point of e power 1 by z. The same you can take the reciprocal, z equal to infinity is the essential singular point of e power z. So for this problem, essential singular point. Sixth question, for f z equal to z plus 3 sine 1 divided by z plus 2 have. So here is the solution. So z equal to minus 2 is the singular point. This fails to be analytic, so that this is the singular point. Now at this point you can see that 1 divided by minus 2, if you apply 1 divided by 0, that is infinity. Sine infinity is not infinity, it is does not exist, the value does not exist. So we can say this is the condition for essential singular point. As like sine 1, sine 2, sine 3, sine 4, etc., sine infinity has doesn't value, so does not exist. Next question. Seventh one, if fz is equal to sin z divided by z minus pi the whole square is. So you can easily analyze that z minus pi the whole square equal to 0, that gives the pole of order 1, or you can substitute this value directly, you will get which is equal to infinity. So this is the condition for pole.